Greetings, fellow skids. This is your Grandmaster Rake. Today I'm going to show you the OpenArena hack source code. I'm going to show you all the different functionality, how it works, and hopefully that will give you a better idea if you're looking to modify it or maybe expand on what I've done so far. Ignore the fact that there are no implementation files here. I've crammed everything into these header files, so just ignore that, please. Let's get started with geometry.h. Basically, this is the Assault Cube vector and matrix class that I really like. It has everything you need and more. It's highly optimized. I've modified it a bit. I've added some of my own functions to it that I needed. Calculate angle, scaling around a fixed point. I have the world to screen, thanks to C5 for supplying that. I had a really tough time figuring that out. We have a vec4 class, which is used for matrix math when you need that W component. And then we have the GL matrix class. And if we scroll down here, this is the Assault Cube world to screen. And then this is the world to screen that I wrote myself, included there. We go to OpenArena-SDK.h. This is the header file. Everything you need to make an ESP and an aimbot in this game is included. All the classes, all the defines, all the enumerators, everything. Really, you don't need all of this, but in case you want to expand on this, you're going to need all of this. Basically, I just went through the OpenArena source code, which is public, and I found all the classes I need and pasted them in here. Now we can go to reversals.h. This is all the OpenArena-specific stuff that I needed to figure out just for this game. So first we have a virtual machine table. Quake engine uses virtual machines. So basically, this is how they were able to achieve portability and cross-platform. You can use Quake Engine, I believe, in Linux, in a web browser, on Windows, on your cell phone, anything really. So there are 3 virtual machines in the table. It can have a max of 3, but it can be just 2 if you're in multiplayer. CG entities, that's basically our entity list. We have G entity, which is for the local game only. It contains your health address that's writable, so you can do unlimited health when you're in single player. I have some game-specific defines. These are all things that you're going to have to change if you port this framework to another game. Game status, we have lobby, game, or bad mod. So if you're in the lobby, the client game virtual machine isn't running. If you're in the game, then you want to execute your hacks. And if it's not a supported mod, you don't want to do anything. So this is the OpenArena class here. It contains all the information just for this game. So again, if you're going to port this to another game, you would erase this and just start over with the class from the new game. So we have a pointer to the virtual machine table. We have a pointer to the client game struct. We have a pointer to the entity array. We have a pointer to the CG_T. That's the local client structure. CGS is a structure. It gets replicated from the server. It contains all the server information, including a list of all the connected clients, which we need. This is just a pointer to that local G entity again. And then we have 2 functions here. Oh, we have 3 functions. We have getVM, which is going to parse the virtual machines table, basically, and it compares them to the ones I've already figured out. So this is just like a switch statement. It compares all the virtual machines to what I've already found. So if the instruction count is this, then we know it's version 88. If the instruction count is that, then we know it's version 85, and so on. And then down here, these are the mods that I don't currently support, and the reason for that is because these were built, I don't know, on a different version. They rewrote basically the source code so that the client infrastructure and the C game structure are different from the rest of the versions. So basically, I have to rewrite my SDK just to support those versions, which I wasn't really interested in doing. Then we have this mod scanner, which I don't recommend that you use. It's a really shitty offset dumper. So if you find a new mod and you want to dump some offsets from it, you can use this. It does take some modification. It doesn't work right out of the box. So next we have our class, our player class. So these are local objects that are going to have pointers to the uh, entity in game memory. So we have a pointer to the C entity. We have a pointer to the client info. We have a variable to hold the screen coordinates, their distance from the local player, and their distance from the local player's crosshair based on angle. The constructor that we use, and then we have three functions. Bool be valid. This is going to check, these are the sanity checks. Is it a player? Is it not the local player? Is it not a spectator? Is it valid? Is current valid true? And then it's going to check this EFDead bit flag and see if the player's dead. But unfortunately, that is not accurate 100% of the time, so I had to supplement by checking the player animations. And if they are death or dead animations, then obviously they are dead. Otherwise, we return true. Be enemy function basically checks if it's a team game and they are not on the same team as the local client, then, or they are on the same team, then return false, not an enemy. Else, it's deathmatch mode and everybody's an enemy. Next is basically just a world-to-screen wrapper for just specific to this game. And then here I declare the vector of player objects. Next, let's take a look at... I'll show you, I talked about that mod scanner. I did write a pattern scan function that I think is pretty cool, but I don't recommend that you use it for this reason alone. It's highly efficient, but the problem with it is that if your pattern contains the byte FF, this will not work. It was my method of combining the pattern and the mask into one byte array. So that's that. Interesting just to check it out, though. It is pretty cool. So let's go to Aimbot and see what's going on here. I use the STD sort algorithm to sort through the target list. And we're going to sort them by angle. So this is the predicate you have to use for that. It takes in two players, and it compares their distance from the crosshair, and sorts like that. Now, if those two players are very close in angle to your crosshair, meaning less than 100, then it's going to sort them by distance. Now, what this does is, if you have two enemies, enemy 1 is in front of you, and enemy 2 is behind enemy 1, you don't want to aim at enemy 2, you want to aim at enemy 1. So that's how that works. Now for the Aimbot class, I have a target lock functionality. We have a pointer to a target, and then we have the functions down here. First of all, read player data. We clear the player array, then we check all the entities in memory and check if they are valid, and if they are, we add them to the player vector. We have a move mouse function, which takes in their 2D screen coordinates. It creates a mouse input struct, and then it sends it in using send input. The reason I had to do this was because I could not find any writable angle variables. If someone can figure that out, I would be eternally grateful. Then we have a get targets function. Right here, this piece here is the target lock functionality. If there's a target, and if target lock is true, then you're currently locked onto a target and you just want to continue to shoot him. You don't want to go getting new targets and sorting them and then switching your target. So if it's target locked, if the target's still on the screen, if they're still alive, then just shoot them and return. Otherwise, we are going to sort the target array. We're going to populate the player array, the target array, by looping through all the players in the player vector and we're going to check if they're an enemy. If they're not an enemy, we continue. Otherwise, we whirl to screen them. We get their distance from the crosshair. We add them as a target, and then we sort the target vector. And then if the target vector is not empty, then you assign a pointer to the best target, and you put target lock as true, and then you move your mouse to them and subsequently end up shooting them. Read hotkeys just checks if you're pressing a hotkey. And one function I've added to this is you get the focus window and you compare it to the window that you're hacking. So if you're playing the game, the hotkeys will work. If you've got it minimized and you're in TeamSpeak or Skype or whatever, you're not going to be activating and unactivating your hacks. So let's move on to ESP. ESP class, it only has two functions here. The first one is just ESP. It's going to loop through all the players in the player vector. It's going to find the center of the character by taking TR base, which is their eye height. Okay, you're going to subtract eye height, so now you're going to be at their feet. And then you're going to add half of their player height. So that's going to give you the exact center of their body. The reason I like to do this is, I don't want to print an ESP box if all you can see is their toe or their hair. I want to see the ESP box if this is going to be a target I'm actually going to be shooting at. So then it checks their world to screen, and then it draws the box around those screen coordinates. So draw boxes right here. What it does, it checks if the enemy is an enemy, then it paints the box in red, otherwise it paints the box in green. This is part of my scaling functionality. We talked about some game-specific defines that you need, and virtual screen width and height. This is when I make a hack for a game, I always do it in windowed mode, and I use a default width and height for the screen. And that way, when I'm testing the ESP and trying to get it just right, I don't have a variable that's changing constantly on me. It's a constant size. So we divide the current window width by the virtual screen width, and that gives you a ratio in comparison of, the ESP in virtual screen coordinates, the box would have been this size, but in the current resolution, it will be in this size. And it also takes into account the distance of the player by dividing the game unit magic by player distance. So every game, the coordinate system is built on a different size of the unit. Assault cube, they called it a cube. I think it was a meter squared. That was the unit. And then this game is different. So if we look at this, it's 4,000 for OpenArena. In Assault Cube, this number was 800, I believe. So that's just something you have to play with until it's scaling the ESP box by distance properly for your game. So after the scaling, it calls GL draw outline, and then it prints the text. So let me show you the GL draw class first. Up here, I just have some variables. Basically, they're just byte arrays for the RGB color values that I use in the hack. And then we have the GL class. A couple functions here. We'll scroll down. Setup, ortho. This is setting up an orthographic projection matrix. Anytime you're doing 2D drawing and you're drawing to a screen, you want to use orthographic projection matrix. And then when you're all done, you want to restore the GL. So the thing with OpenGL, it's a state machine. There is, at any given time, the OpenGL rendering context is in a current state doing a specific thing with all these different bits and variables set. So depending where you're hooking and how you're drawing, you could be overriding all those GL states. And so what you need to do is use GL push attribute. It's going to push all the attributes of that state onto the stack. You're going to turn it into an orthographic projection matrix. You have to disable these things that make your hack not render properly. Then you do your drawing, and then you restore it by popping the attribute, going back to a GL projection matrix, and then calling load identity. So interesting here, GL disable, GL blend. You need to do this in OpenArena, but you do not need to do it in Assault Cube because they don't use GL blend, or perhaps before swap buffers is called, they disable it themselves. So you can check all these, I believe, by using GL, get float v, or get integer v, whatever it is, and then you plug in GL blend. So you can find out what those attributes are set to. It's trial and error. You just got to play with it for an hour or two and you'll figure it out. Some other functionality, center text. Basically, it takes, if you had, this basically pertains to my menu class. If I have a rectangle and I want to center the text vertically and horizontally in that box, I use center text. If I just want to center it on the x-axis, I use this function. It only takes in x and it only takes in width. So that's used for the ESP. You draw the ESP box, and then above it you draw the player's name. So you need to make sure if the player's name is smaller than the width of the box, that you're centering it within those constraints, or if it's larger than the size of the box, that you're centering it properly so it looks nice. Then I just have two basic draw functions here. Draw filled rectangle draws a square using GL quads, and then draw outline, which just draws the border. That's what we use for the ESP. Draw filled rectangle is what I use for the menu. Now, draw outline. I'm using GL line strip here because if you use GL line loop, it actually misses a pixel on all the corners. So I like line strip better just because it makes my menu look nicer. So the next part of OpenGL here is the GL text class, and this 100% credits to C5 here. He gave me this previously in my hacks. Other people on the forum also are using glute bitmap character. Now you don't need that function. You can just use this class. It's short, it's simple, and it works great. And thanks to C5 for showing me how to use it. Basically, there is a build fonts function. It gets the current GL device context, and then it builds a font using create font A. You take the height, the width, all this other good stuff that you can look up on MSDN, and then this is the font I'm using, Consolas, and you can use any of the Windows fonts. And there's a good Wikipedia page that's going to show you all the fonts supplied by Windows 7. List of typefaces included with Microsoft Windows. So you can basically use any of these, and you're guaranteed that this is going to work on anyone that uses the hack. One important thing, though, is that for your scaling and your centering of the text and all that good stuff, to work properly, you need to use a monospaced type font, meaning that every character, whether it's X, P, T, a lowercase a, or an L, or a period, that all those characters have the exact same width. If you don't do that, the centering of the text is going to be kind of crazy. So, an important thing to note here is that you need to get the current device context and build the font. Because it'll build it differently and it won't be applicable to every rendering context. And I'll show you more of that later. Then we have a GL print function, which is very much like printf in the fact that you can put in multiple variables and format that string like that. So you'll see more of that later. Let's take a look. Internal includes.h. This is just something I drop all my include files into. You need to include the OpenGL 32 library, which is included with Visual Studio, and it's also included in the Windows SDK. Detours, I actually included it in the project. If you download the source code, it's actually just in a lib folder. Let's take a look at the menu class. So the base of the menu class is a row, okay? A row that contains text, it has a background, and it may have a border. I put together some defines here to make this easily modifiable, if you want to make your menu a different color, in a different font, in a different size, you can do that pretty easily. Now, this is more just a proof of concept. This is not a finished class. But I have 4 different row types. You're either a hack functionality, you're a header or a footer, or you're a tab. I haven't implemented the tab yet, something I definitely... In the menu class, you have the width of the menu, the height of the menu, the X and the Y. That's going to be the top left corner where the menu starts to draw. We have next row Y, which basically this is... it's how you advance from one row to the next. I'll show you that in a second. We have a vector of rows. We have 1, 2, 3, 4, 5 different functions that I'll show you in a second. So the row, basically, it contains the row type. It contains 2 different possibilities for text. It has a status, because generally the row will be like a function, like an aimbot or ESP, and it'll either be toggleable, you know, on or off. You have the height of the row, and then a pointer to the menu that the row belongs to. So this is my default constructor that I'm using for row, and then row has a draw function. So let's look at the menu function, get menu width. When you create a menu, and each row of the menu is going to have a different, the text string is going to have a different width. So you need to make sure that your menu is large enough to hold all of those. And so the whole idea of this was, I didn't want to hard code and play with this menu for every game I hack. I just wanted to create something that would dynamically create itself. All I had to do was plug in the rows. And so that's what this does. It loops through all the rows in the vector, and it gets string length on the text, and it compares them to the other rows. And when that's all done, you have the longest row string length, and then it assigns the menu width using that. And then we have the build menu function. So basically, if you want to build a new menu for a hack, you just type in the different things you want to be in here, and define each row as a header, a function, a footer, whatever you want. If it has no status, you plug in null pointer, and if it does have a status bool, like aimbot or ESP functionality, you throw in a pointer for that. So it adds these functions to the vector of rows, it gets the menu width, and then this is how I assign the location of the menu. So if you want to move the location of the menu, move these. By multiplying it by the window width and height, it takes into consideration changes in resolution. It doesn't work perfect, but it works pretty good. Also, I have build error. This was just something I threw together fast. It builds a separate menu for when there's an error in OpenArena. For if you're playing a game with an unsupported mod, it's going to print this menu instead to notify the user. So now, when menu draw is called, it's going to set up the orthographic projection matrix. It's going to loop through all the rows, and it's going to draw the row. Then it's going to take that next row Y, which is how you advance from one row to the next, and it's going to add the height of the current row. And then, when it draws the next row, it will be the next row down. Then we draw an outline around it, and we restore the GL state and continue. The row default constructor here, it takes in the menu that you're assigning the row to, the type and the text and the bool status that you want. It defines the height of the row, and if it's a footer or a header, you want to make sure that the height includes the height of the outline. And if the status is not a null pointer, it's going to check the status of status. If it's true, it's going to set the text to on. If it's false, it's going to set it to off. So in row draw, it draws a filled rectangle for the row. If it's a footer or a header, it draws an outline, and again, it increases the advancement by the width of the outline. If it's a function, It's going to center the text. It's going to see if the status is on or off, and then it's going to print it. And you can see here it takes both strings for text1 and text2. If it's not a function, it's just going to print the single string right here. And then if it is not a function, then it just prints the text, and you're done. So I think that's everything. I think we're going to proceed to main CPP. We can see down in DLL main what happens when you inject. It creates a thread called start hack, which is right here. And the way I got this set up is for all the classes that I've defined, it creates a pointer and assigns it to null pointer. And then when you're actually injecting the hack and the hack is turned on, it allocates a new object on the heap and assigns the pointer to that. Then it calls hook SDL swap buffers, which we can go look at that. And right here we see it gets the module handled for SDL, and then it gets the process address of SDL. It assigns, let me look at this quick. Go to the definition. Right, so when I type this function, you can just see how the naming convention I use. T is for a template, and O is for original, and then H is for the hooked function. So it gets the address of swap buffers. It assigns that address to original, and then using MSDetours, we attach from the original to the hooked function. So that's how that works. The reason why I'm using SDL GL swap buffers instead of just regular swap buffers is because if I want to record a video of the hack, Fraps or OBS, whatever the software is, it's hooking GL swap buffers. So you both can't hook the same spot, so it doesn't work. So basically, I just hook before the screen capture software hooks. Alright, so where was I? Main CPP. Then we create this thread called shoot thread. So this is a separate thread that so in the shoot thread it's just a while loop. It checks, is there a target? Is aimbot activated? Are you pressing the right mouse button? If so, it creates a send input structure for mouse event left down. So it presses the left mouse button, it waits 5 milliseconds, then it releases. Now, the reason I like to do this is because this works for every game as long as left mouse button is your shoot button. And the reason you need to wait 5 milliseconds is because you need to wait for the game to detect that you've pressed the left mouse button. So you need to do that. Also, what's great about this is it works for fully automatic weapons and it works for semi-automatic weapons. So I have one function that works for every game for every gun type. That's a done deal for me. And the reason you have to do this in a separate thread is because we're calling sleep. If we called sleep in a hook, it would sleep the actual game thread and your game would pause, and you definitely don't want that, trust me. After shoot thread is created, it detaches it because you want this to run asynchronously. You want it to run completely separate from the game thread. So that works pretty good for me. Now let's check out the swap buffers function here. Once you're injected, the shoot thread is created. It hooks swap buffers, and then the main file is done. Now, the only thing that's happening is every time swap buffers gets called, it's going to do all this, and then it's going to return to the normal functionality of swap buffers, and the game's going to continue. So first thing it does is it gets the OpenGL viewport. So that gives you your window size, width, and height. All this is for one reason right here. You need to check if the menu's been built and the font has been built for the current OpenGL rendering context. If that rendering context changes because you change mods, you change maps, whatever it's going to be, you need to rebuild those things because they're not applicable to other rendering contexts. So it gets the current device context if the font's not built, or the current the current rendering context is not the old one, then we need to build fonts. Same thing, if the menu's not built, we need to build the menu and build the era menu. Then we parse the virtual machine, which I showed you before. That's going to get the mod type, and it's going to assign all the correct pointers. Then it's going to check, is OpenArena in a game? If it is, we're going to read the player data. We're going to do the ESP if we want to. And if it's a local game, we are going to set the unlimited health hack on. And we only want to do this if the OpenArena game, if you're actually playing a game. If you were in the lobby, this would be trying to reach pointers that are invalid and your game would crash. Then we read the hotkeys, which we do regardless of if it's in a lobby or not. If game status is bad mod, we print the error message. Otherwise, if menu is on, draw the menu. And then we return execution to GL swap buffers. So that's everything you need to know. So I hope you guys enjoy it and learn from it.